since Sophie and I argued when I told her that I wasn't going to buy her the purse, she hasn't returned my calls.
My name's Macy, and today we're doing the Anions, Cations, and Ionic reactions lab. So we're starting off with the exercise 1, qualitative anion tests. To begin the experiment, I've clipped some of the ends of these pipettes. I've added 8 drops of bromide into this well, and I've added 1 drop of silver nitrate into this well. And I've recorded in table 1 that the substance seemed to be cloudy in nature. Step 6 includes adding 2 drops of hydrogen chloride to the wells containing the sodium bromide and the silver nitrate. And this is when I added hydrogen chloride, 2 drops of hydrogen chloride, and I did this is like 8 drops of bromide, and this is 1 drop of silver nitrate, and it seems like this one has become cloudier, and I'll put this in my observations. So now I'll repeat the steps 1 through 7 with the remaining 5 chemicals. So I'll sniff off the ends of each of these pipettes. So carbonate, 8 drops of carbonate in well 2. Eight drops of chloride and carbonate in well 3. And well 4, iodide. And sulfates in well 5. And finally sulfide in well 8, 8 drops. Alright, and now I add like 1 drop of silver nitrate, and then I wait a moment. So silver nitrate into the carbonate, into the chloride, into the iodide, yeah. And then into the sulfate, and finally into the sulfide. And I'll absorb these, I'll write down the recordings of each of these. Carbonate, chloride, and iodide, we got the same reaction as bromide, where it became like a cloudy substance. But for sulfate and sulfide, sulfate, like it's still clear, but for sulfide, it could be possibly a precipitation reaction, and it created a blackish solid. So these are my recordings. So now we add 2 drops of hydrochloric acid into each of these wells. So for carbonate, add 2 drops, chloride 2 drops, iodide 2 drops, and sulfate 2 drops, and sulfide. And here are the results. After we added 2 drops of hydrochloric acid to each of the chemicals, the carbonate has become bubbly. The chloride, it's clear now. The iodide, it's the same. Sulfate, it turned whiter, and sulfide, the black solid participant seem to have broken apart. And here's my data. So now we need to find out what unknown solution 103 and unknown solution 104 is by doing all the steps we have done from the previous 6 chemicals. So we need to add 8 drops of unknown solution 103 first to row C of the wells. So 8 drops. Of 103, and then 8 drops of unknown solution 104. Alright. And now we add 1 drop of silver nitrate into 103 and 104. And now I will record the observations. So after adding hydrochloric acid to each of these 2 wells, well, I double checked right here. This one, the identity of this is still unknown, but for 104, it seems to be sulfide. So here are my results. So now I add 2 drops of hydrochloric acid into unknown substance 103 and unknown substance 104. So first is unknown substance 103. And now we think, now I think I know the identity of both of these. So here's the results before we added the 2 drops of hydrochloric acid, and here's the results after we added the drops of hydrochloric acid. So the identity of substance 103 is carbonate, and the identity of substance 104 is sulfide. Now we're moving on to exercise 2, which is qualitative cation test, which includes flame in the anions, cations, and ionic reactions experiment. So I put a pea-sized amount of potassium iodine onto the spatula, and I'm going to hold it next to the fire to see if there is a color change. So let's go ahead and do that. Alright. And we might have to hold this for 30 seconds to 2 minutes to see if there is a color change. Do you see any color change? May have to melt. Okay, it's starting to warm up.
So it's red hot.
It's red hot.
That's not steel, I'll tell you that. That is definitely not steel.
Probably say like an orange's color change right now. Yeah, I'll probably go with pinkish or red. I'll say pink. Alright, let's go with pink for potassium iodide. So the next color test we're doing is with sodium chloride. So, yeah, salt. So let's see what color change this makes.
Oh, it's not gonna melt, babe.
Yeah, but is it going to make a color change?
No. It's not gonna be any color change. Alright, turn just like slightly brown. That's it.
Yeah.
Salt is very hard to. No, its bonds are too strong, babe.
Oh. Yes. Yeah, it's falling in there.
It's probably the residual potassium iodide. It's not sodium.
Alright, well, let's just say that salt has no color. Alright, next we are doing calcium chloride. And we're going to see what color change this one makes. Close to red. So, the next one we have is lithium hydroxide. And of course I washed the spatula before all these tests. So, lithium hydroxide will make a magenta color with the fire. So I have saved the best one for last, which is copper 2 nitrate. And it has a brilliant blue color. Alright, it's starting to dissipate. So copper 2 nitrate makes a green color. So now we have the results for all 5 of the color changes that each chemical has made. So here are the results from data table 2. Alright, and based upon these results we can figure out the identity of the 3 unknown solutions. So we have unknown solution 105, unknown solution 106, and unknown solution 107. So first we're going to test the color change of unknown solution 105 and see which of them, see what color it matches from our 5 previous chemicals. So here we go. Turns black. It has blackened. I don't see no color change. So next we're doing unknown solution number 106 to see what type of identity it has based on the flame color. Do you think that's salt? It looks like the composition of it looks like salt. And it's giving off no color change. And it's not melting either. Do you think that's a color change?
There is no color change occurring.
Yeah, bright orange, but whatever. It's probably just the regular fire.
Showed you my first.
So finally, we're doing unknown solution number 107 right here. So let's see what color change this makes to the fire.
What's that one?
Unknown solution 107. Okay, he's turning into something. I can feel it.
It's melting.
Yeah, it's melting.
So it's not a salt.
It's not salt.
If it's melting, it's more than likely not salt.
Okay, it's turning green. I can see some green.
So what does that indicate?
So it's copper
Has copper in
to
it.
nitrate. Or it has copper in it. So now we're moving into the second part of this exercise. So it says place a pea-sized amount of unknown 106, which looks like this, into an empty well of the well plate right here. So, and then it says use the empty pipette to add 1 to 4 drops of distilled water directly onto the chemical. So let's use water, distilled water, to add 1 to 4 drops. So I'll add 4 drops. Like the previous experiment, we add 1 drop of silver nitrate. And see what chemical reaction it does. Add 2 drops of hydrochloric acid. So let's see if it's, right now it looks like salty water. So let's see what it turns into. 2 drops. And it doesn't seem to be doing anything. We will do the same thing with unknown solution number 7. Where we'll add 4 drops of distilled water to it. Alright. And then we'll add 1 drop of silver nitrate. And unknown solution number 7 has ended up turning cloudy with the 1 drop of silver nitrate. And now we'll add 2 drops of hydrochloric acid. And it has remained the same from when we added the 1 drop of silver nitrate. So that is unknown solution number 7. We are finished with lab 1, anions, cations, and ionic reactions. And this is our results. So thank you and have a nice day.